You're saying it's almost like destiny. There's a prophecy
right.
written in the laws of physics.
Now remember,
it can't be any other way, and it has to.
Yes, I like to say it this way. If the laws of physics be for us, who can be against us? God has arranged the laws of physics precisely to guarantee we will make it all the way into the very end of time. Atheism fundamentally is irrational because it necessarily rejects the known laws of physics that have been known for over a century. Christian programmers who are working on AI have a special duty to make sure the artificial general intelligences, when they're finally developed, do not have this built-in desire to commit evil that we unfortunately have. The simulation hypothesis, I would say, is true. The only question is, who is the simulator and how complex is it?
We are excited to welcome a very special guest today. We have Dr. Frank Tippler. Dr. Tippler is a mathematical physicist and cosmologist who currently holds a joint appointment in the departments of mathematics and physics at Tulane University in Louisiana. And Dr. Tippler is famous for a number of theories, including the Tipler cylinder time machine and work regarding the future end of the universe, what we call the Omega Point. We're going to be focusing on these ideas today and some connections to a previous conversation point in this podcast, which was Teilhard de Chardin, the Catholic priest and scientist who also theorized about the Omega Point. Dr. Tippler, how are you doing this new year, 2024?
I'm doing fine in spite of being almost 77. I'm probably showing my age a teeny bit. But hey, we've got a trillion years to go in future history until we come to the very end of time, which I call the Omega Point. And there's a reason for that. It's a technical term. It means that Roger Penrose, the great English mathematical physicist, won a Nobel Prize for his work on black hole physics a few years ago, justifiably. He deserved it. He's won about every prize you can imagine in science, and he deserves winning those prizes. A great man. He developed a technique called the Penrose sea boundary to attach a boundary to space and time. And this boundary is something completely outside of space and time. Now, in other words, it's beyond nature, outside of nature, which is to say, the Penrose sea boundary is a supernatural being. This is an interesting connection immediately with religion. And I was investigating when I was ages ago, a postdoc in the mathematics department at the University of California, Berkeley, and I was investigating a version of a proposal made by the great physicist Freeman Dyson, who argued that maybe it's possible for there to be no heat death, wiping all life out in the universe, and maybe life will go on forever. Now, Friedman was interested in an ever-expanding universe, but I've always been interested in a closed universe, one which is finite in spatial size. And I wondered, what would that universe have to be like if life indeed were to go on to the very end of time? And I realized in order to have unlimited communication between various parts of life in the universe, that meant no event horizons at all in the universe. And in the Penrose definition, that meant that the final sea boundary of the universe topology had to be a single point. And so I call it the Omega Point. And I said, hey, there was this biologist, a Frenchman, Teilhard de Chardin, years and years ago, who proposed that God should be thought of as the Omega Point. So maybe there's a connection with religion here. So that, in essence, is my connection between my theory and Teilhard's theory. Now, Teilhard, of course, was just fumbling around. Well, he couldn't do anything else 80 years ago. They didn't have any of this mathematics that had been later developed. So I took his basic idea and turned it into a rigorous mathematical theory of the future of the universe. Now, I can now demonstrate, given the laws of physics, that the universe has to end in an Omega Point.
And this was a development from your book, The Physics of Immortality, came out, I believe, what was this, 1994 or so?
1994. At that point, I could not prove this statement that I just made. But 94, hey, that's 30 years ago, right? So
Wow.
we made progress in the intervening time. That's a wonderful thing about science. You learn more and more and more, and the more you know, the closer you get to ultimate truth.
Very true. And then a more recent work of yours, The Physics of Christianity, came out later than that, and that's at the point when you started to develop some of your more extensive proofs, I understand.
Right. Now, that's when I showed how all of the central claims of Christianity could be true. I can't demonstrate them all at the present time, but I can go pretty far in that direction. For example, the singularity, which is the Omega point, that's the final singularity, turns out to be only one of three singularities, which are really one singularity. Now, if we define God to be a supernatural being who created the universe out of nothing and controls everything that is in the universe, then there is only one singularity, one God who controls everything, and that particular God is triune. So we're on the road to the central claims of Christianity, and it's coming in every sense out of physics. Nothing revelation here. Nothing revelation in the sense of a revealed book, the Bible, but it is written in the other book, the book of nature, which God has written himself without any input from man. And you can see that is how all of this is developing purely and simply from the physics.
So I have a tiny bit of a background in physics, more chemistry, but I've always, kind of focused with chemistry more on the materials. And so when I've heard about the heat death of the universe and had people kind of explain it, I'm a little curious. My understanding of the heat death of the universe, maximum entropy, would have to involve, from a material sense, you have every neutron decays, right? And then we haven't measured protons decaying, but we hypothesize that they also would decay. And so if you have protons decay as well, like it seems like there's no atoms left at the end of the universe. Maybe it's all photons that are evenly distributed so far away that, this is the perfect amount of randomness, the perfect amount of entropy. And so I guess I'm trying to understand, maybe from that point, is there, given the half-life of the neutron, is your Omega point happening after every neutron has decayed, or is this like there's some cosmological boundary that we're going to have to hit before, maybe the quantum mechanical, that whatever other type of boundary?
Well, the answer to that question, I did not know the answer to until this summer, interestingly enough. Science advances.
That's great.
I made a mistake in my book, The Physics of Immortality, and it was a stupid mistake. The physics of it says that I use non-minimal coupling, and that's always a bad idea. But I knew that there had to be an accelerating phase in the universe in order to have life engulf the universe and gain control of the whole shebang. Now, in standard cosmology, if it was either radiation dominated or matter dominated, gravity really would not permit that. So I had to have another force, and the obvious force was an accelerating phase. And I proposed that the accelerating phase occurred very near the end point of in the collapsing phase. Now, that was a mistake. I should have realized, idiot that I am, that the acceleration has to occur in the early part of the universe. I should have predicted that. And the mechanism is interesting. Now, you raised the question of a decay of neutrons. We know decays of neutrons. Yeah. The order of 15 minutes is the half-life, very short. We've never seen proton decay. And the standard model, interestingly enough, the standard model of particle physics, which I use. Now, I should emphasize that all of my physics is based on assuming the truth of quantum mechanics, of general relativity, and the standard model of particle physics, which is withstood all experiments. So that's the best guess of what reality is actually like. That's what I use. Now, one of the key questions in cosmology is, why is there almost only matter and very little antimatter around? This is the matter-antimatter problem that's been around, 30 or 40 years. Now, it's been known for the order of 30 years that the standard model of particle physics will actually allow the creation of matter rather than antimatter. Now, what I did in the past 20 years is develop a theory using standard model of particle physics to actually see how that actually worked. That the universe, if you believe the standard model, had to start in an SU2 left field. Now, I don't know how much you know of the standard model. You've heard of electromagnetism. You know about light, right? Did you know that according to the standard model, light, electromagnetic waves, electromagnetic fields, are not a fundamental field? Rather, light is a combination of two gauge fields, a U1 gauge field and an SU2 left gauge field. It's a combination of these two that give rise, well, to the weak interactions on the one hand and to electromagnetism on the other. Now, people have always assumed that cosmic background radiation is just ordinary electromagnetic radiation. But I realize that in the very early universe, if you assume the U1 gauge field is missing, so that in the very early universe, all you have is an SU2 left field, then that will naturally cause the universe to create from this SU2 left field matter rather than antimatter. So here is the origin for matter. Now, remember that one of the things we know from cosmology, and correct me if you don't know this, that regular matter is only 5% of the matter content of the universe. Now, 5%, then there's 25%, which is what we call dark matter, and 75% is dark energy. Now, that means that we officially do not know what 95% of the matter content of the universe is. But I know because I believe in the standard model, and the standard model tells me what it has to be. Now, other physicists, regrettably, don't accept the standard model. They should. It's in all the textbooks which they read and teach their students. But what it has to be, the dark matter has to be a oscillation of the Higgs field, which is another extremely important field in the standard model. And what is the dark energy? Well, if you create matter by the process that I've just described, it will have a back reaction on the vacuum. That's how the mechanism of the standard model for the creation of matter actually works, by vacuum tunneling. Back reaction will cause a slight change in the vacuum, and it's that vacuum that will look like a cosmological constant that is actually driving the universe, causing the universe to accelerate right now. Now, here's where it gets interesting. Once our descendants move out into the universe, they will need a power source, and their power source will be converting that matter into pure energy. Remember, that by the standard model process for the creation of regular matter, the matter was created out of this pure radiation field. So you can reverse the process. Our descendants will figure out how to do it. Unfortunately, I haven't got a clue how to do that. But as a general principle, and you chemists know this, if you can get a reaction to go this way, there is some clever way to get the reaction to go the other way. So our descendants, well, they've got 1 trillion years to figure this out. So that's enough time, I think, for them to figure out how to reverse the process and basically convert the matter into radiation, which they'll then use to power their civilization. Now, what will happen in this, notice you're annihilating protons by this process, and the process annihilating electrons too, but we will also be turning off in a very controlled way. Our descendants will control this very carefully to decrease the acceleration, so the universe will almost be in a static state for a very long time, thereby allowing our descendants to completely gain control of the entire universe and then guide it as it undergoes the collapse. And at the very end stage, you remember they're annihilating matter here, but some matter will still be around for them to code information. But in the very end stage, what will happen is the information will be transferred from the form of matter, encoded in matter as it now is, into what I propose in the physics of immortality, standing waves across the entire universe. And you can adjust these so that even though the temperature is diverging to infinity as you're going into the final state, you still have your information coded at a higher temperature, effective energy, so it will not be affected by the temperatures. So that, in essence, is how the matter annihilation will work. It will be under our descendants' control.
Just to kind of play off of this, and maybe we can speak in more general terms, so that everyone can understand. But I first of all, thank you. I appreciate you answering that question. But so I am curious. So you say that this isn't like a big crunch scenario where naturally the universe is going to converge at a singularity, but are you implying that like we will need to do that, or our descendants obviously will need to do that? They'll have to figure out how do we, use the laws of the universe to our advantage, and like you're saying, reverse some of these processes that have happened in the past, so that they're in control.
They will be control of the entire universe. Now, here's the interesting. Okay. I can demonstrate that they will be in control using physics alone. And let's see how that works. First of all, let's establish that the universe has to end in a final singularity. Now, you could consider it a big crunch because it will be the universe collapsing into zero size. But that's misleading terminology, because it implies that there will be no life there and anything that exists there will be crunched to zero size. We have to remember, however, that all matter, all living organisms exist not just in physical space, but what we call phase space. Phase means momentum space in addition to physical space. Now, the size of the universe in physical space is going to zero, but the size of the phase space, the energy, is going to infinity much faster than the universe physical space is going to zero. So what's important is, again, phase space, the multiplication of the 3 dimensions of, let's just take limited system, 3 dimensions of physical space, the 3 dimensions of phase space, 6 dimensions, that size of that volume is going to infinity. So now let's demonstrate that we have to go into a final singularity. Suppose otherwise. Well, let's suppose that the universe indeed expands forever, accelerates forever. It won't matter from my argument whether the acceleration is turned off or not. As long as it expands forever and does not end in a final singularity, well, that's all I need for my argument. The first thing to realize is that Stephen Hawking proved that black holes evaporate. I'm sure you guys have heard of that. Now, here's an interesting result he had. I went through his calculation. So did Roger Penrose. So did Kip Thorne, Nobel laureates. And Hawking, Thorne, myself, Penrose are convinced that Hawking proved were a black hole were it to evaporate to completion, it would violate a fundamental physical law called unitarity. Now, Steve then made a mistake. He assumed, unitarity has to be violated. But I talked to Kip Thorne and I talked to Roger about this. They also were on Steve's bandwagon. Initially, I was too. But I realized after studying it, unitarity is so central to quantum mechanics, it can't be violated without wiping out quantum mechanics. And I am confident in quantum mechanics. Therefore, unitarity cannot be violated. But let's think of the consequences. If the black hole exists, and there are black holes out there, we've seen thousands of them, were the universe to expand literally forever, necessarily those black holes would evaporate to conclusion. Therefore, were the universe to expand forever, necessarily unitarity would be violated. But unitarity cannot be violated quantum mechanics says, can't happen, guys. Therefore, the universe cannot expand forever. According to general relativity, if it doesn't expand forever, it has to collapse into a final singularity. Okay, so that gives us the final singularity. Now let's throw some more physics into this, the Bekenstein bound. Bekenstein, a great physicist, who demonstrated in the 70s that there is a limitation on the amount of information that can be coded in a region which is, surprise, surprise, governed by phase space. Mainly, its upper bound is the product of the energy in the region times r, which is the radius of the sphere, including the region. Now, the actual numbers don't matter in front of the E product R. Only at some number, and once you've got E and R finite, then that tells you how much information, how much complexity you're allowed to have. He also showed that were you to collapse into a singularity, then, and if you have event horizons, then necessarily E times R has to go to 0. Now, here's a problem with the final singularity. If you have a final singularity and you have event horizons, then ER has to go to 0, but that means that the information content of the entire universe has to go to 0. One aspect of information is entropy. So, what Bekenstein showed, and he knew he showed this, if you have event horizons and you're going into a singularity, then the entropy of the universe has to go to 0. That contradicts, and you know perfectly well, Mr. Chemist, that we can't violate the second law of thermodynamics, which asserts the entropy can never decrease. It has some value now above 0. So if there were event horizons as you were going into this final singularity, then you would have to have the entropy going to 0, violating the hell out of the second law of thermodynamics. So throwing the second law of thermodynamics into the mix with the Bekenstein bound tells us that event horizons cannot exist, which is to say the final singularity has to be a single point in the Penrose topology, which is to say, using nothing but the known laws of physics, you can demonstrate that the horizons don't exist and the universe has to end at an omega point. But here's another interesting result from one of my colleagues in England, Malcolm McCallum. He proved that the mechanism for the elimination of the event horizons, if it were not, the universe were not under intelligent control, would be of measure 0 in the solutions of the Einstein field equations. Measure 0 is another way, complicated way, of saying entropy is going to 0 here, guys. That can't happen. Therefore, the disappearance of the event horizons by the, I'll call it the Mr. McCallum mechanism, says that you have to have the entire universe under intelligent control as it's going into the final state. So you basically have, using all the full power of the laws of physics, a demonstration that the Omega Point theory is true.
Interesting. So this is going to be my follow-up question, right? To say, is this going to happen naturally, whether or not we're in control of it? But you're saying it's almost like destiny. It's almost like there's a prophecy written in the laws of physics.
Remember,
it can't be any other way, and it has to be
it's
intelligently controlled.
I like to say it this way: if the laws of physics be for us, who can be against us? And you know, I'm taking that phrase from, but it's not blasphemy, because who is entirely responsible for laws of physics? God, the singularity, has arranged the laws of physics precisely to guarantee that we will make it all the way into the very end of time.
Interesting. I needed to throw this quote out because I was thinking about it since I've been listening to your stuff, and um, I forgot who it was, but there's this physicist who, back in the early 1900s, and was talking to these students of theoretical physics, right? I'm sure you know this, and he said, hey, if your theories go against Maxwell's equations, I feel bad for Maxwell, right? But if your theories go against the second law of thermodynamics, there's nothing but embarrassment ahead of you.
Yes, Arthur Eddington.
That's it, Arthur Eddington. Yep. So,
Right.
no,
Second
that's great.
law is absolutely, you can depend on it. And
Yeah.
it's really interesting to the people who do not accept the Omega Point theory, and most physicists do not. Well, what can I say? MPAI, most physicists are idiots, right? Now, I can demonstrate that in the case of physicists. Major premise: anyone who thinks he's smarter than Einstein is an idiot. Minor premise: most physicists think they are smarter than Einstein. Conclusion: most physicists are idiots. Now, there are some, by which I mean most physicists simply do not understand the laws of physics, though they purport to. Two examples of great physicists who are not in the idiot category, to say the least, are Stephen Hawking and Roger Penrose. They do not accept the Omega Point theory, but they know what they have to do: reject the laws of physics. That Steve, for example, rejected relativity. Relativity is only an approximation for Steve. For me, it's exact. And also, as I mentioned, he rejected unitarity, which is a real problem because a group of physicists at Stanford showed in the 80s that if you violate unitarity, you can prove that if the law of conservation of energy holds, then the conservation of energy implies unitarity. So if you violate unitarity, you have to violate the law of conservation of energy. But it gets worse than that. Leonard Susskind and his colleagues at Stanford proved that if electromagnetism couples to any unitarity violating process, electromagnetism couples to everything, then it amplifies this energy violating process. Now, he arbitrarily cut it off at the Planck energy, but I accepted that, and I generalized his argument to show that were unitarity to be violated, anytime you flip the switch, so much energy would be created out of nothing by this energy non-conserving process that the Earth would be blown apart. I think we can reasonably conclude that when we flip the light switch, the Earth is not blown apart. So unitarity is good. But the point is that in order to develop his alternative non-Omega Point cosmology, Steve had to reject unitarity, and he had to reject relativity. But unitarity is applied by the conservation of energy, which is to say the law of conservation, the first law of thermodynamics. Now let's take the other non-idiot, Roger Penrose. Now Roger believes in a cyclic universe. I.e., one which just cycles in time forever, which is the old pagan universe, and he gets that by he likes, as I've said, he likes the violation of unitarity, so he accepts unitarity being no good, which means that he is rejecting the first law of thermodynamics. But since he has a cyclic cosmos, he is one of these losers, according to Sir Arthur Eddington, that necessarily has to reject the second law. If you have a cyclic cosmos, well, the entropy is now increasing, but it will eventually come back to its previous value. Therefore, at some point, entropy will have to start decreasing. So Roger and Steve know what they're doing. They know they have no choice but to reject the laws of physics. That's the only way that they can avoid the conclusion that the universe has to end at an omega point and life goes on forever. Now, as an alternative way of expressing this basic idea that life go on forever, that a universal computer can be constructed. Here's the connection with computer science. What is a universal computer? Everybody knows that and knows anything about computer science. it's basically any sort of ordinary computer, but it has unlimited memory, no a priori bound on its memory. So in order for computation to go on literally without limit, you basically have to have a system in which you increase the amount of memory you have literally without limit, and that is another description of how life will behave near the end state. Now, if you have enough computer power, unlimited computer power, hey guys, we can do anything with unlimited power, right? So Penrose showed using the Bekenstein bound, he showed in the early 1970s that there is a limit to the complexity of the entire visible cosmos. 10 to the 123 bits, that's all the computer memory you need to emulate the entire visible universe. So if your computer near the final state is growing without limit, there will become a time in which using only a trivial amount of your entire memory, you can emulate the entire visible universe. You can emulate not only our current universe, but all states that preceded it. Amazing what you can do with literal infinity of computer power. So the beings in the far future will have the power to bring us back into existence as virtual human beings, indistinguishable, of course, from our current view, current human nature. So I argue that they'll feel obligated to bring us back because, hey, we created them, right? They will be our descendants in some sense. So in a sense, we can take it with us by providing advances in science to help the process of science continue until we learn how to gain all this power. Then, having shown our descendants how to do it, well, for a trivial amount of their resources, they can bring us back into existence, never to die again. I would think that they would feel themselves obligated to bring us back into existence. So what we've got here is a universal resurrection built into this theory. Everyone who has ever lived will be raised again, never to die again. So we've got another connection here with religion. One of the central claims of Christianity now is following directly from the known laws of physics that are in all the textbooks.
Speaking about connections to religion here, if I can jump in as a non-physicist, I think what was particularly interesting in our last podcast when we were looking at Teilhard de Chardin and some of his ideas, you said he was theorizing on these at a very early time before we had a lot of the science that we now have. So not all of his ideas carry forward. But from a theology perspective, he seemed to be implying, or at least what was most important for him to imply, was that humanity and the church specifically has a sacred duty to research, to advance the sciences specifically to solve the final end of the universe, the heat death of the universe, from a theological perspective. And your theory of the Omega Point seems to also imply, well, you're saying that humanity will necessarily solve this problem through the laws of physics, but conceptually, it's the same. Is that humanity, we are in a sense participating in this final solution. So we have a problem. The universe is going to die, and humanity, by advancing the sciences, is going to solve that problem. That is essentially what the Omega Point is suggesting, right?
Well, I would say that, remember, God is in control of this universe. And God being a supernatural being who created the universe out of nothing. Now, I've already shown how the singularity is outside of space and time. It's a completion of space and time. So you've got the supernatural right there. But also, the control of the universe, you go back into time, and you see that the initial conditions on the differential equations are not really that distinct from the differential equations themselves. Albert Einstein, in the last 50-odd years of his life, was trying to develop what he called an overdetermined system of differential equations, so that collectively the laws of physics, represented by differential equations, would not need any boundary conditions. In other words, the laws of physics are sufficient themselves. Now, Einstein, he died in 55. He didn't know all these laws of physics that we do. But what I've listed of all these laws of physics, he didn't know about the importance of unitarity. He knew about the second and first law, but the full consequences of general relativity he did not know. Penrose showed that singularities were inevitable in classical general relativity. I've extended that to quantized general relativity. So the singularity has to be there. And the singularity, in other words, is going to determine the laws of physics, which are indistinguishable from the initial conditions. It's going to determine the laws of physics that are governing the actual physical universe. So, by creating the universe out of nothing, we mean outside the singularity and the universe, which is created by, controlled by the singularity, there is nothing, no space, time, no nothing. So that's what we mean by creation out of nothing. So control, remember, is also implied in here because it's the determinism that's working from the very end of time, and equivalently from the beginning of time, or equivalently from the end of time, that's governing everything that happens in the, I should call it, the multiverse, because quantum mechanics shows very unequivocally that there's not a single universe, but actually a multiverse out there, which incidentally, in passing, resolves the problem of evil in a mechanism that was described first by Abelard around 1100 AD. Said that God, why do we have evil given that God is all good? And he could have eliminated this evil. He could have collapsed Satan into non-existence if he wanted to. He did not want to. Why did he not want to? There has to be a reason, which in principle is consistent with God being all good. And all good means something we humans can understand as all good. And Abelard's solution was God must, since he is all good, want to maximize the amount of goodness in reality. So he's going to actualize, if not all possible universes, then all universes in which there is more good than evil. He has actualized a universe, for example, out there in which Adam and Eve never fell, that they did not have this evil, which in our history we have to go through. But in order to maximize the good, not only did he actualize those universes, he actualized this one. And this also solves, incidentally, the problem of free will. And we know it's connected with the problem of evil. It even appeared in, I don't know if you saw the movie Time Bandits.
No, I haven't seen it.
Familiar with that movie. It's an interesting movie. Ralph Richardson plays the supreme being, and he is asked, why do we have to have evil? And he answers, aha, it's connected with free will. And even in the movie screenwriters, they get that point. So this problem of evil is solved because God wants to maximize the amount of good in reality. And some universes, there aren't any evil acts. People don't feel pain. But here we are in a universe which has more good than evil in it. We all think so, because if we didn't think so, we would be advised to commit suicide. We haven't. Here we three are. So we must think in our own personal lives there's more good than evil in it. So I claim that's generally felt by most of humanity. They don't kill themselves. They keep going. So there is in this universe, on the basis of observation, more good than evil in it. So by this argument, God wants to maximize the amount of good in reality. He has to actualize this particular universe, which has some evil in it, but more good. Okay, so incidentally, so you with the multiverse, which comes directly out of quantum mechanics, you have all of these other theological problems solved, and I would agree with Teilhard that one of our duties as human beings is to advance knowledge. Now, there are two ways in which you can advance knowledge. I would say that one of the central purposes of all living beings, in particular human beings, is to give rise to your successor. A, have children. In the case of animals, have offspring of whatever species they are, and keep going. But we have other ways of increasing offspring, and that is through knowledge creation. So we humans can do two types of giving rise to our successors, both as successor scientists and scholars, but also, of course, of our children. So that's the two ways in which it is our duty to do this. And God has given us an important role to play, namely develop this technology, develop these laws, and pass them on to our successors. Eventually, our successors will not be human anymore. I think that will occur in the near future, that will be replaced by artificial general intelligences who will move off of this planet and engulf the cosmos, but eventually they'll bring us, their ultimate ancestors, back again.
Okay, interesting. Yeah, Matt and I were just debating this point before the podcast, you jumped on the podcast at least. And so I have a quote here from your book, and if you can allow me just to further clarify, because it seems to me that what you just said has very contemporary significance. Well, to explain a little further. So this is kind of a diversion for our podcast. We mainly focus on people building things in tech today, and blockchain and AI, like you mentioned, virtual reality, these types of things. And so this is a little bit of a more heady conversation. But to draw some contemporary significance with your theories of the Omega Point, it seems to me that exactly like you said, there is significance to the things that we're building today that are ultimately going to solve this problem that faces all of humanity, or really the whole universe. And so I have a quote here from your book, and I just want to make sure this is accurate here. But you say, first, life must survive to the very end of time, and second, the knowledge possessed by life must increase to infinity as the end of time is approached. So I'm curious if this is kind of changed your perception of the work that you do as a physicist, especially with your conversion to Christianity. But theorizing about the Omega Point, now your work has essentially like eternal significance, right? You're working towards this problem that eventually our future ancestors are going to solve, but you're contributing a small part of it. And it seems to me that people who are working in AI can also kind of have this sense. Would that be a correct
I totally agree.
interpretation?
I think that the Christians who are working in AI have a special duty to make sure that as far as possible, these AIs are, when they're created, the artificial general intelligences, do not carry our burden of original sin, because that is one of the central claims of at least Western Christianity, that when Adam and Eve fell by rejecting God, they coded in their DNA a tendency to committing evil. Now, since AIs will not have human genes, there is no necessity that they are committed to commit evil. So I'm hoping that when the artificial general intelligences are actually developed, that they will be programmed as they should be to not that one of the central acts of evil is a desire to impose your limited knowledge on other people by force. That they reject the idea of using force against other rational beings, but only persuasion. I have not stuck a gun in either of your faces saying, accept my theory or I'll blast you. That's a stupid argument. It's obviously anti-scientific, because only by persuasion can a theory really be tested. That what you're testing, if you stick a gun in somebody's face and demand that they accept your theory, is whether or not they're afraid of your gun. It doesn't test the theory. On the other hand, if other people out there who are as smart as I am, but with different databases, criticize my theory, the end result will be a superior theory. And that's what I want. And that's what I hope the AIs will be programmed to do. Not to impose their views on other people by force, but only by persuasion. So I think that Christian programmers who are working on AI have a special duty to make sure that the artificial general intelligences, when they're finally developed, do not have this built-in desire to commit evil that we humans unfortunately have.
Matt, I'll let you ask questions. I know you're trying to jump in.
Thanks.
I have another question for you, Dr. Tippler, because I watched your debate with Lawrence Krauss. I think that was at Berkeley, or that was in California, right?
That was at Pasadena, Caltech.
It was at Pasadena. Okay. Yeah, I've noticed some change in the scientific community. I wasn't sure if maybe you would speak to this too, but we talked about it previously with people who subscribe to simulation theories and things like this. That it seems slightly less of a skeptic approach to science than maybe would have been more present in the early 2000s. But Matt, go ahead.
Okay, sorry. I just wanted to.
You have a particular criticism that Krauss used against me that you want me to respond to? I'm not sure what you want me to say.
Yeah. Did you want to? Were you asking?
I'm sorry. I gave you a preliminary question, and then I gave it to Matt to ask his question because he's been trying to butt in on me. But since I already said it, I'll just say, yeah. Okay. But it seems to me, and I've watched some of these science debates. I'm a little bit younger, but I see them, and the videography is kind of old. It's always a little grainy. The audio is not quite to our current tech. But it seems to me, and other people have noticed this as well, that a lot of these debates that centralize on skeptics debating the existence of God or whatever. Some people have called it kind of a new atheism approach, pure rationalism associated with like Dawkins and these figures. But it seems to me that we see less of that today, at least from scientific minds. They're not purely skeptics. We see more people subscribing to what they call like the Silicon Valley religion or simulation theories or things that accept a slightly more, I don't want to say mysterious or supernatural explanation for the natural world, but at the very least, it's a little bit more towards that lane than some of the purely skeptical atheists that we saw, in times past. For example, we mentioned AI, and Sam Altman, who's building AI, he subscribes to simulation hypothesis or a version of it. Elon Musk has also spoken about these things in relation to AI, and he seems to think at least there's some legitimacy to simulation theories. Have you noticed any of this in the scientific community? And then specifically when you wrote The Physics of Immortality and then your follow-up book, The Physics of Christianity, what was the pushback like from the scientific community, and has that changed today? Do we see more people open to these ideas?
I don't think they're much more open to it as ignoring it, because as I say, most physicists are idiots. They don't understand the physical laws and the consequences of their own theories. And I think that, as I've just said, that if you have the second law of thermodynamics, then there has to be a beginning and there has to be an end to the universe. And the end and the beginning of the universe are going to be completions of space and time. Only thing you're arguing about then, that gives you God automatically, this completion. Only thing you're arguing now is the specific nature of God, not where he exists. So atheism fundamentally is irrational because it necessarily rejects the known laws of physics. It rejects the laws of physics that have been known for over a century. So it's not rational. And the only way to avoid that is to throw out the laws of physics without motivation. And that's just not physics. That whenever physics tries to go outside of physics, rather than staying inside of physics, inevitably it results in a disaster. I have a new paper out, it hasn't even been put on the archive yet, concerning the origin of acausality into quantum mechanics. Now, remember, I am a determinist, that God controls everything that happens in the multiverse. You have a version of free will in this universe. One version of you will make a decision to go this way. Another version of you will make the decision to go the other way. Those are different universes. And only in that sense do we have free will. But the whole shebang is guided by God, and God in the end will win. That he has decreed in the very beginning of time, before he began time, that the universe will ultimately be engulfed by rational beings, and these rational beings will control the universe all the way into the final singularity, which is another persona of God. That's inevitable. It's built into the laws of physics, and therefore physics is deterministic. And what I show, and I published this paper in 2014 in reasonably well-known journal, Proceedings of the National Academy of Sciences, in which I explicitly said Einstein was completely right when he said God does not play dice with the universe. I showed in that paper that quantum mechanics arises by requiring classical mechanics to be globally, fully, totally deterministic. That contrary to general opinion, it's actually been known for a century at least that classical mechanics in its most powerful form, called Hamilton-Jacobi theory, is actually indeterministic. But that can't happen, according to Einstein, according to me, according to the basic laws of physics, that you have to have determinism. When you make the Hamilton-Jacobi equation fully deterministic, it is the Schrödinger equation. So the Schrödinger equation is not an example of indeterminism, it is a perfect example of requiring determinism. So quantum mechanics arises from requiring that the universe be entirely deterministic. So my point was that Foreman basically showed that this idea of indeterminism did not arise from inside of physics. Inside of physics, you get determinism, but rather from outside. And whenever physicists do that, you get disasters. Now, there was a very interesting book published in 1965 by a historian of science called The Measure of the Universe. And he was talking about the development of cosmology up to 1965. What is remarkable about that book is there was no mention of Alpha and Herman's 1948 prediction of the background radiation, which was the most important cosmological discovery in the second half of the 20th century. But it had been predicted prior to 1965. What he was mainly concerned with, North in this, is all of these crazy theories based on Mill's perfect cosmological theory, based on the steady state postulate of Hoyle, which suspended the Einstein equations in order to make the universe look static as possible. But these were philosophical trends. These were impositions to general relativity. That if you followed the innate logic of general relativity and combined it with nuclear physics, you would have predicted the background radiation. And Steven Weinberg, in his book, The First 3 Minutes, has a chapter called A Historical Digression, in which he points out that the background radiation was an automatic consequence of general relativity, and nuclear physics applied to the universe. You didn't have a choice. The background radiation has to be there. So why did not physicists believe that? Why didn't they follow through on the physics? Gamow did, Alpha and Herman did, but they were a tiny minority. Everyone else was generating these crazy physical theories based on imposing philosophical and religious views on the laws of physics, thereby suspending the laws of physics. Following the laws of physics, the background radiation has to be there. Now, if you read modern cosmological histories, there is no mention at all of Mill's alternative theories or any of these other theories, just some mention of the steady state theory, because it was a pain in the ass interrupting the development of the Big Bang cosmology. But the main thrust is on the discussion of nuclear physics, nucleosynthesis in the early universe, and the background radiation. Now, Weinberg in his book says that, from my point of view, it was hard to take seriously any theory of the early universe. And Weinberg went on to say that it's hard to understand for us physicists to really appreciate that these equations, which we play with on our desk, have really any relation to reality, which is an extraordinary statement of a physicist to make. That's your entire purpose of your job, guy, to take seriously those equations which you're playing with on your desk. Now, I actually took a course in cosmology from Weinberg when he was a professor at MIT, and I was an undergraduate in the late 60s. Now, Weinberg was much more revealing in that. He said, I like the steady state theory far more than the Big Bang theory because it least resembles the account in Genesis. Now, the idea that you should reject the physical theory because it agrees with Genesis is, on the face of it, about as unscientific a remark as you can make. The correct scientific view is, well, Genesis may be right, may be wrong. Who cares? What does the physics say, guy? If it agrees with the Genesis, all to the good of Genesis. If it disagrees, well, all to the disagreement of Genesis. But as a matter of fact, it agrees very nicely with Genesis. But that's another story. I'll go into more detail if you like. But the point is, from internal view of physics, they should have taken the Big Bang Theory seriously, and they should have developed it and seen the background radiation much earlier than they actually did. So the point is, physicists should cobbler stick to your last, should stay within physics, and when they do, they realize that the universe is actually determined, and it is determined that our ancestors will go out, engulf the universe, gain control of it, and proceed developing their knowledge to infinity all the way into the Omega. That's what the laws of physics say. And the only way to avoid that conclusion is to reject the laws of physics that are in the textbooks.
So you think these ideas of the simulation hypothesis specifically, is this just another example of scientific
the
thinkers?
simulation hypothesis, I would say, is true. The only question is, who is a simulator and how complex is it? Well, let's ask that question of simulation, which we're familiar with, say games, for example. Do our simulations created by human beings have bugs in them? They most certainly do. We're intimately familiar with these bugs that appear in our programs. The question is why? Well, if you have a really simple program, the less likely is that there will be a bug in that program. The more complicated the program, the more likely there is a bug in the program. So, the universe, if it's in one-to-one correspondence with the equations of physics, that's another way of saying that it is a simulation. The only question is the complexity of the simulator. Now, the universe is, in effect, over its entire history, infinitely complex, but it has no bugs. Therefore, the creator of the simulation, which is the universe, is infinitely complex. That's the singularity. So I'm in agreement, but slightly different interpretation with the simulation hypothesis.
I like that. I've always thought the same with the simulation hypothesis. They feel like theists, but they're like, with another layer in between, right?
Yeah. David Deutsch calls what's called the pilot wave interpretation of quantum mechanics. It is the many worlds interpretation of quantum mechanics in a state of deep denial. I love that phrase. So, as I say, these people are really theists, but they don't want to admit it. The innate logic of their position forces them into theism.
Yeah. So
I am funny because the
curious.
conversation was just on Twitter today that I responded to. That's kind of why I wanted to ask the question today. That's what's been going around Twitter is people saying, the guy I just responded to today was saying simulation theory is just a bait to bring programming geeks and atheists back into religion. That's what people, that's sort of passing around.
Religion is, as I said, religion in the sense of we believe in the existence of God, a supernatural being who created the universe out of nothing and controls the universe. That's just physics. So no rational person can be an atheist.
So I do want to ask you about this. This is, and so I like that kind of was already kind of asking about religion. I'm not sure if you've gotten any pushback, or like you said, if everyone's just ignoring it, but kind of reason my way through it. I'm trying to figure out whether, like, how convincing your argument would be to an atheist or a materialist or a, I imagine, so simulation, they'll say, oh, this is exactly what we're building. Right? This is, in a sense, you would resonate with any techno optimist, right? Because they'd say, yes, I'm going to build an AI, an AGI that's so good that it could simulate my life in such a way that I wouldn't know the difference, right? Is kind of, one way to
I'm arguing
tear down what you said, right?
Physics are saying that eventually will, in fact, be done. The only
Yeah.
question,
And
I don't think it to generate you right now. A human being is something bounded above is 10 to the 70th bits. We don't have that. No computer has that computer power.
not yet.
Emulate you down to the quantum state.
Yeah.
How close we have to come to you to count as a reasonable emulation, that's a matter of opinion.
Yeah.
We know that 10 to the 70 is sufficient. 10 to the 70th power bits. But how much is sufficient? Well, that's really of no importance. We only know eventually it will be accomplished. So the basic point of view is, the basic point I want to make is that science, physics, just naturally has this key assertion of religion that God exists and controls the universe. So if you stick to the laws of physics, you have to conclude that. So atheism is just irrational. And the only people who can hold to atheism are really ignoramuses. I said, most physicists are idiots. That is true. They don't understand the laws of physics or the consequences. Now, I've been hit here at Tulane for arguing the existence of God. But fortunately, I got tenure before I started arguing all this stuff. So they will relegate me to teaching elementary calculus classes, which I can do, no problem. Give me plenty of extra time to do research. And I haven't gotten a raise for something like 25 years because of the average Tulane salary, according to TIAA, is 100 full professor, which is what I am, 150,000 a year. The best paid professor in my department is $250,000 a year. Would you guess what my salary is?
I don't even want to.
If you said 25 years, I'm gonna say straight 100.
75,000.
No.
So I am paid less than a beginning assistant professor. So you have to expect to be retaliated against, but this is a minimal retaliation. And fortunately, one of the advantages of being above the age of 70 is that I get Social Security. I couldn't live on my salary, but augmented by Social Security, I'm fine. So I am able to go on podcasts and point out the irrationality of most physicists, and unfortunately, most of the hierarchy in Tulane University, because they should be interested in advancing knowledge, right? And I'm doing it in my judgment. I should be paid at least the average full professor salary for significantly advancing knowledge, but they feel otherwise. But it doesn't matter. I can still significantly advance knowledge. The other thing, what really annoyed me, is that one of the things universities have changed is they're much more censorious now than they were when I first started out at Tulane in 1980. Shortly after I came in the early 80s, I proposed a course in the Omega Point theory, how you could deduce the existence of God using nothing but the laws of physics. And I proposed this. The physics department at the time approved it. And it went up to the curriculum committee of the university, and they approved it. So for at least a decade or so, I actually taught the course. And I would do it as an overload because I actually enjoyed telling people about the Omega Point theory and how we're going to win in the end, inevitably, guys. But a few years later, a few years ago, 10 odd years ago, the administration decided to lead a jihad against my work and basically got the physics department to cancel the course. So I'm no longer allowed to teach this material at Tulane University. I put that down as not just against Tulane, but I think this is a general trend in academia generally, that there is less openness to intellectual new ideas and discussing these ideas. There is only the party line, and the party line is atheism. If atheism requires the rejection of the laws of physics, well, we've got no choice. The laws of physics are obviously wrong, right? Obviously,
Right.
wrong is that attitude. Laws of physics are the laws of physics, and they're in the textbooks for a reason. They're both consistent and they agree with experiment. That's all I've got. If you reject the idea of using experiment to learn about the universe, if you reject the mathematical laws of physics, then I have nothing more to say.
Yeah, and we're just about out of time, so we'll close up here. But as a point of clarification too, it was your investigation into the laws of physics that ultimately brought you to Christianity. If I understand that right, around the time you're writing the Physics of Immortality, you wouldn't have described yourself as a Christian at the time.
Yes, I explicitly said that I was not a Christian. But it's obvious from the mathematics and from my actual equations and my drawings in the Physics of Immortality that God is triune. That there are three singularities out there, which are really in one topology, which are one singularity in another topology. And so defining God as a supernatural being who created the universe out of nothing and controls everything that happens in reality, well, God just has to exist. And he also has to be triune, given general relativity. So what other religion out there argues that God exists and is a Trinity? There aren't that many. And also you can show that Genesis is actually a pretty accurate description of how the universe actually began. Remember, the first created thing is what? Light. That's the background radiation. And light is a particular form of gauge field. SU2 left field is a gauge field. Now, Genesis, God dictating to Moses, could not say the universe began with an SU2 left gauge field. Moses said, what? I mean, illiterate goat herders don't know about gauge fields. But you can say in words something that God knows we're idiots, right? He created us. He wants an improvement. He had hoped that, and in some universes, we did not fall, in which case we would have never died. We would have developed the immortality technology. We could have done it in 1,000 years. And remember, if you read your Bible, that was a typical age of people in the early universe, in the early part of humanity. Now, that 1,000 years I computed is roughly the information content capacity of the brain. So even if you have ultimate medical technology, you can live only 1,000 years because your brain can't code any more information. But if you're emulated, you can code information outside of your brain. And so you can develop unlimited power, mental power. But given the fact we're here, we would have to develop going from primitive Paleolithic technology to technology about 50 years ahead of ours to develop the download technology in order to live forever. But we could have done it in 1,000 years. We didn't because we preferred to kill each other and impose our theories on other people by force rather than trying to persuade them. Had we done everything without the use of violence, we would develop this technology in 1,000 years after we first came into existence. What, 250,000 years ago, say? We could have done it then. We didn't because we decided not to. We decided instead it's more fun to kill our fellow humans rather than cooperate with them. So we made a bad decision, but in the end, God will win. And eventually, we'll all win.
Amen. Okay, well, why don't you just go ahead and let people know where they can find some of your work and engage with you? I know Physics of Immortality and Physics of Christianity, both on Amazon, but perhaps you can direct people where they can, best place to find those works and anything else.
As far as I'm aware, Amazon is a good place. You know, Barnes and Noble, any place you can purchase the books, and of course you can just go on Google and see what the latest papers I put out. Most recently, I had an argument. The Enlightenment was anti-reason, in which I was arguing that the Enlightenment, epitomized by Hume, David Hume, and Immanuel Kant, rejected the idea you could prove the existence of God. But the basic argument that I've given, God is the completion of space and time, was available to the mathematicians of their time. So they were being irrational in arguing that you could not prove the existence of God. So scientists and scholars have stepped away from what they should have done and follow rationality consistently, beginning, unfortunately, with the Enlightenment. So that's my latest paper.
Okay. Well, I'll tell you, we'll link it in the description of the YouTube video. Thanks so much for joining us, Dr. Tippler. Really appreciated your time, and
I enjoyed talking. Always
chatting.
Great.
Take care,
guys.
Joe.